Am I audible? Okay, good morning, everyone. Mm, So, in the last classes, we were discussing about third module, and there we have seen what is AC circuit. Okay, so we were discussing phasor representation of sinusoidal quantity. So, phasor means we know that it is a vector which is having both magnitude and direction. Uh, and we have also seen what is trigonometric, rectangular, polar, and complex form. That means uh, in rectangular or Cartesian form, a phasor is represented by x plus jy. So that is a formula for a vector. And in polar coordinate system, it is represented by r at an angle. And we have also learned formulas to convert from polar form to uh, Cartesian form and also Cartesian form to polar form. In trigonometric uh, method, a phasor is represented by r into e raised to j phi, where e raised to j phi is nothing but cos phi plus j sin phi. And the formula to convert from polar form to rectangular form is x is equal to r cos phi, y is equal to r sin phi. And while converting rectangular to polar, the formula was r is equal to x square root of x square plus y square, and phi is equal to tan inverse of y by x. We have done some numerical also. And next portion of the module is analysis of simple AC circuit, purely resistive, purely inductive, purely capacitive. And then we have, in that same topic, we are going to learn about inductive and capacitive reactance, concept of impedance, and average power process. Okay, so, and also after that, so first we will learn about pure inductive, pure resistive, pure capacitive circuit. Then we will analyze the combination of all those things. Resistor and inductor, combination of resistor, capacitor, combination of resistor, inductor, capacitor. And that's about the first part of this module, and later we will discuss three things. So this is what we were discussing in the last two classes. So this is the last we are in the class. Voltage equals A and B. So we have numeric sources. We have plus expression called from rectangular form, and then we have added both, and in the end we have converted back to polar form. Okay, we will see types of AC circuit. So AC circuit is basically is classified into three basic types. That is purely resistive circuit. That means the circuit is having only are you able to see the circuit diagram? Okay. Types of AC circuit. Okay. Uh, there are three basic types of AC circuit. First one is purely resistive circuit. Second one is purely inductive circuit. Third one is purely capacitive circuit. So first we will discuss what is purely resistive circuit. A circuit diagram is called a purely resistive circuit when only resistive components are available in that circuit. So in this diagram, you can see that there is an AC source. The instantaneous value of that AC source V is equal to Vm sin omega t, and it is connected to a resistor. There is no other component is present. There is no capacitor, there is no inductor, nothing else. Only resistive component is placed there. So it is called a purely resistive circuit. Okay, why it is called purely resistive circuit? Only resistive components are placed. Here you can see that there is an AC source, that is V is equal to instantaneous value V is equal to Vm sin omega t, and it is connected to a resistor. Okay, we are going to analyze what will happen to its current when this voltage is applied. What will happen to the current through the resistor or through the circuit when this voltage is applied? That is what we are going to do. That is what the meaning of analysis. So, so this is a circuit diagram. There is a AC source, a resistor is connected parallel to that. So current will be flowing in this manner. There is no other path for the current to flow. Will flow only in this manner. So I am denoting that current as I. That current is I. So I think let the alternating voltage applied across the circuit be given by equation V is equal to Vm sin omega. So what I have done is that we know already. Okay, whatever voltage we are applying, I'm writing it down. Okay, there is no change in that. For all circuit, for all inductor capacitor, there is the same V is equal to Vm sin omega. So let the alternating voltage applied across the circuit be given by the equation V is equal to Vm sin omega t. So it is written here. And now what about the current? So what will be the current through this circuit? So the current is, we know that voltage divided by resistance. So voltage is actually Vm sin omega t. There is a AC voltage we are applying. And divided by resistance is the current. So further I can simplify because I am writing like this. Vm divided by R sin omega. So there is a formula of current. It is very simple. This particular derivation is very simple. So normally they won't be, this won't be asking for semester exam, but as a basic you have to learn. Vm divided by R sin omega t. So next step, what I can do is Vm divided by R. I can write current Im. Voltage divided by resistance is current. So Vm divided by R I can write Im. So it is sin omega t. So this is the formula for current waveform. I is equal to Im sin omega t. So there is absolutely no difference between the first voltage equation and current equation. So voltage equation was V is equal to Vm sin omega t, and current equation is I is equal to Im sin omega t. So that is what we got here. So where Im is equal to Vm divided by R. Now we have two formulas. Okay. V is equal to Vm sin omega t. I is equal to I m sin omega to help you for. Okay. So I'm asking which one will be leading in this one, which one will be lagging, or it is in the same phase. Can anyone answer? Which one will be leading, which one will be lagging, or both if both are in the same phase. So what is the answer for that particular question? There are two equations, V is equal to Vm sin omega t and I is equal to Im sin omega t. So my question is which one will be leading or which one will be lagging or whether it will be in the same phase. ആരെങ്കിലും പറയടോ ആൻസർ. Okay, now let us analyze the condition of leading and lagging. Suppose V is equal to, there is a waveform V is equal to Vm sin omega t. Okay, whether a current or voltage waveform, whatever it may be, in order to say it is leading or lagging, it will be something in this format. Okay, sin omega t, either an angle will be added or subtracted. Okay, if it is added, we can say that the second waveform is leading. If omega t plus phi is there, that means we can say that the second waveform is leading the first waveform because an angle is added. Uh, if suppose it is 90 degree, that means if there is a waveform like this, so if the second waveform is omega t plus 90 degree, what will happen is uh, it will go like this. That means, okay, sorry, if this is the second waveform, this is the second waveform, and this is the first waveform. So take this blue color waveform as a reference. Okay. So if this is of omega t and this is omega t plus 90 degree, then means you can look into this diagram. Who is it crossing zero first? This waveform is the waveform which is in red color crosses zero first than the second waveform. That means we can say that the first waveform is leading, second waveform is lagging. But in this case, in our case, you look at the equation, there is no plus or minus 5. Both are of same phase. So this particular waveform is of same phase. So they have written waveform like this. You can see that there is a voltage waveform which is actually in blue in color, and the second waveform also exactly in phase with the other one, which is in violet color. You can see that both are crossing zero at the same time. There is no phase difference at all. But if you closely observe the magnitude, you can see that the magnitude of violet color, that is current waveform, is lesser than the magnitude of voltage waveform. You can notice that. Why it is? We know that it is exactly from the formula because voltage is Vm sin omega t. Uh, Current is actually divided by resistance value. So the current value will be always lesser than the voltage. That is, we know. Okay. So V is equal to Vm sin omega t. That is a voltage waveform. What is the expression for current? Vm sin omega t divided by resistance. So the current waveform will be always, the magnitude of current waveform will be always less than the magnitude of voltage waveform. So we got a waveform there. And looking at the phasor, since both are of moving at or rotating at same angular frequency, you can see that the waveform of current is drawn exactly on the wave. So the phasor of current is drawn exactly on the phasor of voltage. There is no phase difference. But here also you can notice that there is a magnitude or there is a difference in magnitude because of that resistance. So it is, if the phasor is like this, suppose if this is voltage, if this is current, I can say that if you look at the anti-clockwise direction, the current is leading than the voltage, or voltage is lagging. Okay, or if current is here, I can say that voltage is leading or current is lagging. But in this case, both voltage and current are of at same phase. So I can say that it is in phase. There is no phase difference between voltage and current. So that is about the analysis. So this was simple. Okay, first you have to draw the circuit diagram. First you have to draw the circuit diagram. Then you have to say that the input what we are applying is Vm sin omega t. And then later you find out what is the current equation. In this case, it is voltage divided by resistance. So V divided by R. And so V divided by R, then we will get the current formula I is equal to Im sin omega t. So both the equation having sin omega t, that means there is no phase difference. The waveform will cross zero exactly at the same point. But while drawing the phasor, you have to draw current phasor of current exactly on the voltage phasor because there is no phase difference. But please note that the magnitude of current should be always less than the magnitude of voltage. Okay, so is it clear? This is about analysis of pure resistive circuit. So you can see that another explanation. This is both are same pure resistive circuit. The resistor is connected. AC source is there. Voltage is equal to Vm sin omega t. So current we got Im sin omega t. So while drawing the waveform, you have to draw like this because both are in phase. If you look at the waveform, both black and red color waveform crosses zero at exactly at the same point. But the magnitude of red color is lesser than the magnitude of black color. That means because of the resistance. And look at the last point. The power is always positive. Why it is always positive means we know formula for power is equal to V into I. So analyze the first half cycle. For the first half cycle, both the voltage and current are positive. So positive into positive, it is positive only. For the next half cycle, both the current and voltage are negative. So negative into negative, it is also positive. That means power will be always positive. That means it will flow from source, that is this voltage source, to the load. Load is nothing but your resistor. So all of you understood? Okay. Now let us go for purely inductive circuit. Okay. What's the change from the previous circuit diagram and this circuit? Now, instead of resistor, we have an inductor. Remaining everything is same. The applied voltage is equal to V is equal to Vm sin omega t. And instead of resistor, we have kept an inductor. So we are going to analyze what will happen to the current when this particular voltage V is equal to Vm sin omega t is applied here. This is same like Vm sin omega t divided by resistance, or if there is some difference. But look at the formula. I'm going to break the suspense. That means look at the formula. V is equal to Vm sin omega t. But look at the formula of current. I is equal to Im sin omega t minus pi by 2. That means there is a phase difference. That means who is leading? Voltage is leading because it is minus pi by 2. Omega t minus pi by 2. That means voltage is leading. If suppose uh, this is the uh, waveform of current, so this will be the waveform of voltage. That means voltage is leading the current. So how is it is leading? How the voltage is leading? That is what we have to find out by analyzing the circuit. Okay, now let us analyze how it is uh, coming. Okay. Look at the slide. So analysis of simple AC circuit, that is done through a pure inductive circuit. So you can see that there is a voltage source of magnitude V is equal to Vm sin omega t. So there is an inductor which is connected parallel to that AC source. Okay, we know that what will happen to the inductor when we are connecting an AC source. What will happen when current flows to the inductor? There will be a magnetic field created that we already know. Okay, so inductor stores energy in the form of magnetic field. So when we are applying a voltage, it will uh, generate a magnetic field, and the energy will be stored in the form of magnetic field. And also there will be a voltage that is generated across the inductor that will oppose the flow of current. Okay, we have learned that as part of Faraday's law and Lenz's law. So when we are giving connection like this, so initially current will be flow through the uh, inductor and it will generate some magnetic field across it. And because of this magnetic field, uh, there will be also voltage generated. That voltage will be opposing the current. It will always in the direction that will oppose the force change, producing this changing flux. That is as per the Lenz's law, it will oppose the voltage. So what I'm doing is I'm just analyzing the EMF formula. We know that self-induced EMF, there will be all self-induction because of this winding, because we have also covered that topic. Okay, when there are two winding, mutual induction will happen. When there is only one winding, uh, within that winding there will be uh, some form of voltage induced because of the self-induction. So what is the formula for self-induced EMF? So self-induced EMF is equal to E is equal to L di by dt. Or you can simply learn that the formula of an inductor is equal to V is equal to L di by dt. There is a formula of self-induction. Self-induction, where L is the self-induction or self-inductance. So this is a voltage across an inductor. Formula for voltage across an inductor due to self-inductance. So this formula you have to learn V is equal to L di by dt. So if you look at this formula, okay, again, first you have to draw the circuit diagram and then you write the sentence when a AC voltage is applied across an inductor, alternating magnetic field is created due to the field. A self-induced EMF will be set up in the inductor that will oppose the applied voltage. Okay. So the formula is equal to VL di by dt. So if you look at this formula, so this formula is having a current return, that is di by dt. So we have to find out what is I from this formula. Again, V is equal to L di by dt. From this formula, we know what is voltage already, because voltage is nothing but Vm sin omega t. That we know already. L is a constant, and we have to find out what is I. So V is equal to L di by t. So from this formula, we have to find out what is I. So how to find out what is I? Because we have a term di by dt, we have to find out I from this. For finding out what is I, we have to integrate the formula. That means when we are integrating, this di by dt will become I. Okay. So what I have done is the same thing. Look at the equation. So I'm moving all the terms to the left hand side. So we will get V divided by L into dt is equal to di. Di. So from this formula, we get di is equal to V by L dt. So for finding out what is I is integral of this formula. Integral of di is equal to integral of V divided by L dt. Okay, so that is what is done here. You can look at the formula here. This part of the formula. So after integrating, I is equal to 1 by L. I am taking outside of the integration because L is constant. Integral of V dt. That what is changing? That voltage is changing every time because it is instantaneous value. With the angular frequency, the value of instantaneous value will also vary. So I will get a formula I is equal to 1 by L integral of V dt. Again, how this step has come? So formula was V is equal to L di by dt. What I am doing is I am writing, again I will write V is equal to L di by dt. From this equation I can write di is equal to V dt divided by L. So then I am integrating both the terms. So integral of di is nothing but I, and integral of V dt by L. So L is a constant, I can take it outside. So 1 by L integral of V dt. Now this voltage waveform, V means actually what? Instantaneous value. So from this equation, because we are giving a voltage of Vm sin omega t, I can rewrite this V is equal to Vm sin omega t. So now the term becomes 1 by L integral of Vm sin omega t. Okay. So 1 by L integral of Vm sin omega t. Okay. Again d. So it is not d omega t, it is d. Now what will happen? How to integrate? I can take again Vm is a constant, it is the peak value of AC waveform, so I can take it outside. So Vm, what is the integral of sin omega t? Integral of sin omega t എന്തായിരുന്നു? പറ ആരെങ്കിലും പറ. Integral of sin omega t is integral of sin omega t dt. Okay, minus cos omega t. Because it is dt, I have to write minus cos omega t divided by omega. Okay, we know that if it is cos t, or if it is sin t dt, we can directly write cos t or minus cos t. Since it is sin omega t dt, I should write minus cos omega t, that is integral of sin omega t divided by omega. So the first term has become Vm divided by omega L minus cos omega t. Okay, then I am taking the minus sign outside. So minus sign here I am taking outside. So minus Vm divided by omega L. Cos theta is nothing but sin 90 minus theta. So I am rewriting this one. Cos theta is sin 90 minus theta. Then, so that is what the step what we have followed here. Minus we have taken outside and minus Vm divided by omega L. Instead of cos omega t, I am writing sin 90 minus omega t because the sin 90 minus theta is equal to cos theta. Sin 90 minus theta is equal to cos theta. So again, there is a minus sign. So in order to cancel that minus sign, what I am doing is I am reversing it. 90 minus theta becomes theta minus 90. So now the formula is I is equal to Vm divided by omega L. Vm divided by omega L sin omega t minus 90. And finally, okay, I think still this is clear for you. And after this step, what I'm writing is, we know that something or voltage divided by something is always current. Okay, voltage divided by something, some term is always current. So I can write Vm divided by omega L is equal to Im. So I is equal to Im sin omega t minus 90, where Im is Vm divided by omega L. We know that voltage divided by a resistive term is always current. So omega L is a resistive term. Since it is an inductor, it is nothing but, it is not resistive, it is reactive. So I am writing component as reactive component XL. ഓക്കെ സോ നമ്മൾ ഓൾറെഡി പഠിച്ചതാണ് എന്താണ് റിയാക്ടൻസ് എന്താണ് റെസിസ്റ്റൻസ് നമ്മൾ ഓൾറെഡി പഠിച്ചതാണ്. റെസിസ്റ്റീവ് സർക്യൂട്ടിൽ മാത്രമേ റെസിസ്റ്റൻസ് ഉണ്ടാവും, കപ്പാസിറ്റീവോ ഇൻഡക്റ്റീവോ സർക്യൂട്ട് ആണെങ്കിൽ റിയാക്ടൻസ് ഉണ്ടാവുന്നതാണ് നമ്മൾ പഠിച്ചത്. So voltage divided by omega L is nothing but current. So omega L should be a reactive term. I can write omega L is equal to XL, that is inductive reactance. Inductive reactance XL is equal to omega L. And again, next step you can see that omega is nothing but 2 pi f. So I can write 2 pi FL. So as discussed earlier, we got two terms like this. And one is voltage is leading and current is lagging. So the waveform is like this. So voltage waveform, you can see that like this. And current waveform is lagging by 90 degree. So it is lagging by 90 degree because it is a pure inductor. If it is not a pure inductor, it will be lagging by an angle. Not exactly 90 degree, some other angle. Less than 90 degree, 0 to 90 degree, it will come any angle. So there is a difference between voltage and current waveform because of the inductor. When an pure inductive circuit is applied, the voltage is leading, current is lagging. So you can see that in the phasor diagram, so we are not exactly worried about magnitude. You can see that in this diagram, the magnitude of current is always less than voltage because voltage divided by something is current. So whenever there is a constant like that, the voltage current value will be always less than voltage value. So look at the phasor. While drawing phasor also, you have to draw current phasor in such a way that the length of current phasor is less than the voltage. So here you can see that this is current. The reference axis you can see the current phasor, and by 90 degree the voltage phasor is leading in the anti-clockwise direction. So that's about the analysis of pure inductive circuit. Okay, let me take that. Anastotion.
Sir.
Anasto. Anasto.
Present, sir.
Recessive. Dhyan.
Present, sir.
Pathimanita. Pathimanita online കാണുന്നുണ്ടല്ലോ. Safa.
Present, sir.
Kana.
Present, sir.
Jyotish.
Present, sir.
Kailas.
Present, sir.
ഇത് നീ എഴുതി വെക്കാനായിട്ട് കണ്ടിട്ടില്ലല്ലോ.
സാർ അത് 1 മണിക്കൂറിനുള്ളിൽ ചെയ്യാം. 2 ചോദ്യം കൂടി എഴുതാൻ.
മുഹമ്മദ് മുവാസ് സർ.
Present, sir.
നീഹ ഷെർ.
Present, sir.
നിഖിൽ ദാസ്.
Present, sir.
പ്രണവ്.
Present.
സായൻ.
Present.
ഫാത്തിമ ഇല്ലല്ലോ. Okay, so that's what we are discussing today. We are discussing about pure resistive circuit and pure inductive circuit. We have seen that in a pure resistive circuit, both the voltage and current are in phase, so there is no difference in waveform. Only the difference in waveform is the difference in magnitude. And we have seen the pure inductive circuit, so there is a small derivation. First, you should know what is the equation of a voltage across inductor, that is L di by dt. From this equation, you just integrate, you can complete this derivation. Very easy, no? It's so difficult. So you get I in this form, that is Vm divided by omega L sine omega t minus 90. So that's the final form. Okay, first you have to convert this sine into sine 90 minus theta. In order to neglect that negative sign, you have to use omega t minus 90. Okay, so finally we will get an equation. From this equation, if you compare voltage equation and current equation, voltage equation is Vm sin omega t, current equation is Im sin omega t minus 90. That means current is lagging behind the voltage. Okay, current is lagging behind the voltage by 90 degree. You can draw both the waveform and phasor according to that. ഓക്കെ, ഇത് ഇന്ന് തന്നെ പോയി പഠിക്കുക. കാരണം എന്താണെന്ന് വെച്ചാൽ ഇനിയുള്ള 4-5 ടോപ്പിക്ക് ഇതിനെ ബേസ് ചെയ്തിട്ടുള്ള കാര്യങ്ങളാണ്. ഇത് ഈ ഒരു കോൺസെപ്റ്റ് മനസ്സിലാക്കി കഴിഞ്ഞാൽ